Okay, welcome to Sotantra education. In the previous lecture, we have discussed how to display a text as output in Java. In this lecture, we are going to discuss some arithmetic computations in Java. So let us consider a simple program to perform the addition operation. Okay. Now assume this program we have written class test, then public static void main string args system.out.println 2 plus 3. So for better understanding, let us give line numbers to this program, and we have previously discussed that line numbers are not a part of the program. We give line numbers for our reference only. So this is line number 1, line number 2, line number 3, line number 4, and it is line number 5. So the line 1 defines a class test, and in line number 2 we have written the main method, and line number 3 is a statement that is printing 2 plus 3. So when you run this program, you will get the output as 5. If you compile and run this program, you will get output 2 plus 3, that is equal to 5. So let us take a close look at why this output is generated. So line 3 of this program, that is system.out.println 2 plus 3, computes the addition of 2 and 3 and prints the result 5. But if we write 2 plus 3 inside double quote, then what is going to happen? Suppose for example we have written this. So we are writing 2 plus 3 inside double quote. So the line number 1 is same as the previous one, line number 2 is also same. So in line number 3 there is a change, and 4, 5 are also same. So in the previous case we are simple writing system.out.println 2 plus 3. Now in this program we are writing 2 plus 3 inside double quote. Then if you run this program, you will get the output 2 plus 3. Because if you write anything inside double quote, so that is going to be printed directly on the screen. Okay. And we have previously discussed that a variable is a named memory location that may be assigned a value by the program. So we have discussed that variable that is equal to a named memory location or a memory location that is given a name, and the value to this variable is assigned by the program, and we know that the value of a variable may be changed during the execution of the program. Suppose we are taking a variable x, the name of the variable is x, and if you assign 5 to this variable, or if I write x equal to 5, so generally we can see in this way that x is a memory location, or it is like a box, and the name of the box is x, and we are assigning the value 5 to it. So we have discussed this type of scenario in the previous lecture. Now we are going to discuss another program that shows how a variable is declared and how it is assigned a value. So now move to another program, this one. Okay. So for better understanding, like our previous ones, give line numbers here, line number 1, this is line number 2, then line number 1, line number okay. So now if we compile and execute this program, we are going to get the output like this. The value of num is 100. The value of num 2 is 200. So if we run this program, we will get the output like this. The value of num is 100. The value of num multiplication 2 is 200. So let us take a close look at why this output is generated. So here you can take this one. Okay. So we have discussed about the line number 1 and line number 2 multiple times. Now come to the line number 3. So here we have written in line number 3 int num. So this line declares an integer variable num. So int num means we are declaring an integer variable num. That means the num variable is going to store only integer values. So Java requires that variables be declared before they are used. So first we need to declare a variable, then we can use that one. Okay. So the next line is line number 4, that is equal to num equal to 100. So line number 4 is num equal to 100. So this assigns num the value 100. So num equal to 100 means we are placing 100 in num. So in this way you can see, or we have a variable num and its value is 100. Okay. So the next line, that is line number 5, is system.out.print the value of num is, and here you can see it is print and the value of num is written inside double quote. So it is going to print the value of num is, then you can see a space here after is on the screen, and it is not going to generate a new line. That means when the next output is generated, it is going to start on the same line. Here you can see on the screen it is going to print the value of num is space, and the next output 100 is on the same line. Why? Because here we are using print. So if it is println, then a new line character is added. That means the next output that is going to be generated will be placed in the next line in println, but in print it is same line. So I am writing here, in print it is same line, the next output, in println the next output is in next line. Okay. Now in line number 6 you can see system.out.println num. So it is going to display the value of num. So what is the value of num? So the value of num is 100. So it is going to display the value of num, that is 100. So we are getting this output, the first line, the value of num is 100. So this line in the output is resulted by line number 5 and line number 6, or we can say line number 5 and line number 6 produces the value of num is 100 on the screen, or displays the value of num is 100 in the screen. Okay. Now come to the next line, that is line number 7. So line number 7, num equal to num multiplication 2. So here it assigns num the value of num times 2, or we can say here this star is treated as a multiplication in Java, and the value of num is updated to 200. So 100 multiplication 2, that means 200. So we can say in this way, previously the value of num was like this, it is 100. Now this 100 is updated with 200, because we are computing num multiplication 2, that is 100 into 2, 200, and that is assigned to num. Okay, now num is 200. Then come to line number 8, that is system.out.print the value of num multiplication 2 or num star 2 is. So it is similar to line number 5. So it is going to display the value of num multiplication 2 is some space on the screen. Now come to the next line, that is line number 9. So system.out.println num, so it is similar to the line number 6. So it is going to display the value of num, that is 200. So line number 8 and line number 9 displays this statement for the output, or at the output, that is the value of num multiplication 2 is 200. So the output, the value of num is 100. It is from line number 5 and 6. It is from line number 5 and 6. Next, the value of num multiplication 2 is 200. It is for line number 8 and 9. So I hope this is clear to everyone. The variable names such as num in this example actually corresponds to locations in the computer's memory. Now every variable has a name, a type, and size, and a value. So I am writing that one. So every variable has a name, then also have a type, and also size, and also a value. The size depends on the type. Now in this program, num refers to the name of the variable. So when we execute this statement in this program, num equal to 100, the number 100 is placed into the memory location corresponding to the name num, like we have discussed previously. So the variable is like a box and its name is num, the name of the box is num, and when we execute num equal to 100, the value 100 is placed into the box. Now after execution of this statement, this one num equal to num multiplication 2, the value of num is updated to 200, like the 100 is overwritten by 200. Now the value of num becomes 200. So to use a variable, you declare it by telling the compiler its name as well as what type of data it can store. So we need to tell the compiler its name and the type. The variable declaration tells the compiler to allocate appropriate memory space for the variable based on its data type. Now when we write int num, so it is a variable declaration. It tells the compiler to allocate the required memory or appropriate memory space for the variable based on its data type, that is based on int. Now to declare a variable, the syntax is like data type, then variable name. So the examples you can see in this program we have written int num, or similarly we can take some other examples int count, or we can write double radius, then we can write double edge, like this. So here int num declares num to be an integer variable. Similarly int count declares count to be an integer variable. Similarly double radius declares radius to be a double variable. Similarly double edge declares edge to be a double variable. So here the num, count, radius, edge refers to variable names, and int, double refers to data types, or we can say int, double are the data types. So similar to int double, Java defines 8 primitive types of data, and these are like this. These are byte, then short, then int, then long, then char, then float, then double, then boolean. So Java defines these 8 types of primitive data. So the primitive types are also commonly referred as simple types. So you can give number 1, 2, 3, 4, 5, 6, 7, 8. So these are primitive types or simple types. So the first 4 types hold integers. The byte, short, int, long hold integers, or the 4 integer types like byte, short, int, long, these 4 different integer types are distinguished by the range of the integers they can hold. So in the next slide we will see this one. So what is the size of long, or the width of long is 64 bits. What is the size of int is 32 bits. What is the size of short? It is 64 bits. What is the size of byte? 8 bits, like that. So what is bit or bits I am writing here? So any data value stored in the computer's memory must be represented as a binary number, that is a string of 0 and 1, because we have discussed that computer understands only binary language. So any data value stored in the computer's memory must be represented as a binary number or in the form of zeros and one. A single 0 or 1 is called as a bit. So a bit means either it is a 1 or it is a 0. So a string of 8 bits is called as a byte. So if we consider or take a string of 8 bits, so it is 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7, that means 8 bits. So if you consider these 8 bits, or it can hold 8 number of zeros and ones, so this is called as a byte. So 1 byte equal to 8 bit, and this byte data type refers to a single byte of memory, that means 8 bits of memory. Suppose we want to store 5, we want to store 5 in using byte data type or in 8 bits. So for that we know that for 5 it is 1 0 1, the rest are 0 0, like that. So the rightmost 3 cells are filled with 1 0 1 and the left 5 are 0 0 0, like that. So similarly, short takes 16 bits, int takes 32 bits and long takes 64 bits. Now the range values depends on the size of the bit. So byte can store the integers from -128 to 127. Similarly, short can store the integers from -32,768 to 32,767. Similarly, the range of the integer is like this and range of the long is like this. So how we are getting this -127, -128 to 127 for byte? So here you can see the size of byte is 8 bit. So 8 bit means 8 number of zeros and ones it can hold, and as it stores sign numbers, that means it also store positive numbers and also store negative numbers. So the leftmost bit is reserved for the sign. Now using the 7 bits, it can store -2 to the power 7 to 2 to the power 7 minus 1. So the range is like this. So if you compute minus, the range is -2 to the power 7 to 2 to the power 7 minus 1. Similarly, short takes 16 bits. So the range you can compute, that is -2 to the power 15 to 2 to the power 15 minus 1. Similarly, you can find the range in this way, -2 to the power 31 to 2 to the power 31 minus 1. Similarly, long is for 64 bits. So you can find the range like this, -2 to the power 63 to 2 to the power 63 minus 1, like this. So in this way, the primitive types long, int, short and byte differ by their range and by their size. Obviously, the range depends on the size or width in bits. So now the float and double types that we have written here. So we have discussed first 4 types. Now come to the float and double. So the float and double types, these represents the real number, or these data types are going to hold the real numbers. For example, 3.6, 7.9, -135.79, etc. So real number means these numbers have a decimal point like 7.9, 3.6, minus 135.79, like that. So both double and float are going to store this type of real numbers. Then how they differ, double and float? Similar to different integer types, the double and float differ with their size or with their weight, and depends on the weight they have different range. So the weight of float is 32 bits and the weight of double is 64 bit, and the range of 32 is this one, and the range of double is this one. And how these values are computed? So these values are IEEE 7.754 representation that we will study later. Okay. Now we have another that we have written, that is character or char. So a type variable char holds a single character from the Unicode character set, and a variable of type boolean holds one of the two logical values, that is either true or false. So character you can find this one, a single character, it holds a single character, like you can say this capital A, capital B, small a, small b, like this. And generally these single characters are written inside single quote like that. And we have another variable that is another type, that is boolean, and it is going to store two logical values, that means either true or false. So boolean can hold either true or false, so it has two values only. So next we will discuss about the literals. So now we are going to discuss about literal. So literal is a constant value that appears directly in a program. So for example, if we write int age equal to 34. So we have discussed previously that here age is a variable name, int is a type, and 34 is a literal. Similarly, if I write double weight equal to 0.305. So here you can see double is a type, weight is a variable, and 0.305 is a literal. An integer literal is assumed to be of type int. So generally we assume an integer literal is of type int, whose values is between minus 2 to the power 31 to 2 to the power 31 minus 1, like we have discussed just before. Or you can see here we have written the value of integer is minus 2 to the power 31 to 2 to the power 31 minus 1. Okay. To denote an integer literal of the long type, we need to append the letter, this capital L, or we can write small l to it. Suppose we want to write that, or we want to denote that 2, 1, 2, 4, 3, 7 is of type long. So for that we should write this L at the end or append L to that. Otherwise by default it should be integer. If you do not append L, then by default it is going to take as integer. Similarly, for the real numbers, the by default floating point literal or the by default real literals are treated as double type. Suppose for example we can say 5.0 is double, 7.3 is a double. So if we want to make it a float, we need to append capital F or small f at the end. Suppose if we write 5.3 f, then we can say it is of type float. If we write 5.3 small f, then we can say it is of type float. Okay. Now Boolean literals are simple. They have only two logical values that a Boolean literal can hold, that is either true or false, or we can say true and false are two literal values that a Boolean literal can hold. A character literal is represented inside a pair of single quotes like this one, A, Z, or we can write @ so inside a single quote the character literal is going to be represented. So string literals in Java are specified like they are in most other languages by enclosing a sequence of characters between a pair of double quotes. So single quote means if we write a single character inside a single quote, that is a character literal. So if we write a sequence of characters inside double quote, then that is a string literal. So for example we can write hello inside double quote, so it is a string literal. If we write Java inside double quote, then that is a string literal. So these two are, you can say, string literal. So string literal is used or is specified by enclosing a sequence of characters inside a double quote. Now we will execute the programs that we have discussed earlier. So here you can see the class name is test, and that's why the file name is test.java. We have given test.java, you can see. Now move to the F drive, because we have saved our program in the code folder inside F drive. Then give the command javac test.java for compilation. Then java test for execution. It gives 5 as output. So you can see we are getting 2 plus 3 as output if we write that inside double quote. Similarly, we will write another program that we have discussed and see the output.